Hey guys, welcome back. Now I'm going to start working on a new sensor, that is TSL2561. It's a light sensor, and to gain more knowledge about this sensor, let's have a look over the website, that is controleverything.com, and here search on for this sensor, that is TSL2561. And here we go. As you can see, it's a light-to-digital converter 16-bit programmable gain I2C module, and these are some of its features. You can also purchase the sensor from here. For this video tutorial, I'm going to interface the sensor TSL2561 with a Raspberry Pi and a Java code. So for the Java code, let's go to Resource tab, and here comes the Java code sample. You can have the Java code sample as zip file from here. Also, you can have the code from github.com, and the repository there is Control Everything Community. Now connect some hardware and let's have a look over the connections we need. Now coming to the hardware section, first of all, our requirement is the light sensor TSL2561. And now we require a Raspberry Pi, which you are able to see on my screen, and these are the GPIO pins of the Raspberry Pi. Now this here is an I2C shield. It is available on the website controleverything.com, and we are using it to make connections with other I2C devices and to make further connections a lot easier. So gently place over this I2C shield over the GPIO pins of the Raspberry Pi. Now the binding factor to make a connection among the sensor and the shield is this, a connecting cable. Make the connection for the sensor regarding the cable, and while making this connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor and for the shield also. Now we need to power up our Raspberry Pi, and for that we require a micro USB cable just like this, and gently insert it on the power jack. Finally, for the last part, we require an Internet connection, and there are two ways. First of all, this is an Ethernet cable or a LAN cable, as you can see, and gently insert it over the Ethernet jack. Finally, we can have the alternative way, that is a wireless USB nano adapter, which you are able to see on my screen. It is also used for Internet connection. So we are done with the connections part. Now what we require is to have a code, and let's interface with that. Now for the interfacing of the sensor along with the Java code, we have to log in to github.com, and here we have to search for the repository, that is Control Everything Community. Here you go, and here search for the sensor TSL2561, and here we are with the Java code. Now let's have a look over the instructions first. We have to download and install Pi4j library on the Raspberry Pi and pi4j.com. This link will help us to install the relevant library, and you can see. Now do it carefully. Now this is the command to compile, and this is to run the Java code. Now get back to the code, as you can see, and it's a .java extension file. Now we have imported some of the libraries, as you can see on my screen, and we have created a public class TSL2561. Now we have bus.getDevice, which will have the address of the sensor, that is 0x39. Now in the writing part, we have to select control register having power on mode, and the command for that is here. Similarly, we have select timing register, and the command for that nominal integration time is equal to 402 ms, and the writing command is here. The first part is the address of the timing register. This is the command for the nominal integration time. So we are done with the writing part. Now let's have a look over the reading part, and here we are reading 4 bytes of data for channel 0 and channel 1 from the address 0x60C having OR with command register 0x80. After that, we have the conversion of the data takes place, which is according to the formalities we have to fulfill given in the data sheet for TSL2561. At the very end of our code, we have the output data on the screen. As you can see, we have full spectrum, infrared and visible values. It's perfectly formatted for 2 places of floating point value. As you can see, the lux is the unit. Now what we require is to have a look over the practicality, the working of this code along with the Raspberry Pi and the sensor TSL2561. For the working environment, first of all, we have to copy this entire Java code, as you can see on my screen, and open up the terminal for the Raspberry Pi via internet. Here, create a new file 2561.java extension, as you can see on my screen, and paste the entire code here and save it. Now what we require is to compile, as you can see on my screen, 2561.java for the compilation, and here we go. It's done. Now this is the command to run the Java code, and we have the values for full spectrum, infrared visible rays. Now what we require is to apply some source over the sensor, and you can have the change in full spectrum, visible and infrared values, and it's decreasing as you can see on my screen. Yeah, there you go. So this is how it responds to a source object. But when I place some light source over the sensor, you can see the increase in the values for full spectrum, infrared and visible. So this is how it responds to the light source. Now we have seen the working. Now what we require is to have a look over the applications and the benefits and the features for the sensor TSL2561. The TSL2561 is a light-to-digital converter that transforms light intensity to a digital signal output capable of direct I2C or SMBus interface. This device combines one broadband photodiode and one infrared responding photodiode on a single CMOS integrated circuit capable of providing a near-photopic response over an effective 20-bit dynamic range. It's applicable in a lot of applications like notebook, tablets, PCs, LCD monitors, light control, street light control, security lighting, sunlight harvesting, machine version, and a lot more. This sensor is available on the website controleverything.com and you can purchase it from there. Also, you can have the code from there. The resource tab is there and you can download the code as a zip file. Now you can also have the code from github.com and the repository there is Control Everything Community. In the end, I would just like to make it clear that if you are left without fully understanding any part of this video or sensor, you can have your queries on controleverything.com and you can post your comments on community page of this website. For blogs and articles, you have a look over instructables.com. You can go there, and also to subscribe more video tutorials like this, you can have a look over our YouTube channel. So I hope you enjoyed this video and thanks a lot for watching.